I am Said Reza Fattahzadeh. I am an electrical engineer with over 20 years of experience in the field of both education and developing PLC programs for industry. I am admin of PLCGOODS.com site, and these video lessons on CODESYS PLC Programming tutorial for beginners are prepared by the PLCGOODS team. I am super excited to teach you how to use the CODESYS software to simulate your PLC control application programs. With that said, let's move on to the first video lesson. After a short introduction, we will learn what the IEC 61131-3 standard is. After that, the video will show how CODESYS can be downloaded from the internet. Also, we will use it to write and test a simple program. Let's start with the industrial automation pyramid. As you know, each PLC brand uses its own software. In this course, we are going to learn CODESYS programming software, which can be used to program several PLC brands such as Schneider, Beckhoff, and ABB. Alright, in the beginning, each PLC brand had its own programming language. So a multitude of different languages were created. As a consequence, there was a lot of confusion and difficulty in converting a program code from one system to another. But if you watch our course, you notice the programming languages for these three brands are similar together. Because the International Electrotechnical Committee issued a standard to unify the software architecture and programming language for PLCs, making the PLC systems of different brands more similar to each other and making sure that the software structure and programming languages were the same for all the systems. The IEC 61131-3 standard defines three fundamental aspects of the PLC software structure. Let's start with the first one. Programming organization units, which are the smallest entities in the PLC software. They can be of three types: programs, function blocks, and functions. This diagram displays a simple structure of programming organization units. Each PLC can do one or more tasks. The program or PRG unit is the main programming unit of the PLC software and is the only unit that can be directly called from a task. Note that each PRG unit is unique within the PLC software and cannot be duplicated or used multiple times. Each PRG unit can call others, such as functions or function blocks. All programming organization units will be explained and used during the course. For now, let me tell you the main difference between function blocks and functions. Function blocks need a memory space to store and use some parameters, and they can be duplicated by using another memory space. For example, a function block can be used to write one program to control the speed of two motors with different parameters. Although one program is used for the two motors, their parameters should be saved in separate memory spaces. On the other side, functions don't need memory space to store parameters. For example, a function can be used to compute a formula. Note that we don't need to store any parameters after receiving the result. Note that all programming units, according to the IEC standard, are composed of two parts. The declaration is where all the variables belonging to the programming units are defined, and the implementation is where the actual programming unit code is written. The second main part of the IEC standard explains the variable types of each programming organization unit. Variables are data containers located in a portion of the controller memory on which various types of operations can be performed. Two very important aspects of the variables are their visibility and type. The visibility means which programming organization unit can read or modify a variable. The type determines the type of data that is represented by the variables. When a variable is defined, it is necessary to clarify its visibility and type. There are 5 basic types of visibility of a variable that can be specified. The first one is local variables, indicated by the var or VAR symbol, which is a part of the current programming organization units or POU and can be read or modified only within the current POU. Other programming organization units cannot access these variables. The next one is input variables, indicated by the var input symbol. The current POU can only read them. Output variables are indicated by the var output symbol, which can be modified only from the POU itself, not from its outside. Also, we can define input-output variables that can be read or modified by the current POU. Finally, there are variables that are not part of the declaration of any programming organization unit. The global variables can be read and modified by any programming organization unit in the project. Now, let's see different types of variables. As you know, 1 bit is the smallest unit to store 2 states, false or true. This data type can be used to store the state of many types of equipment in industries that have only 2 states. For example, a lamp can be on or off, or a push button which is pressed or not. If we extend the number of bits to 8 bits, then we will have 1 byte that can be represent 256 states. See this table. We can store 0 with 8 zeros, 1 with 7 zeros plus 1, and similarly numbers 3 to 255. Note that there are lots of standards to use bits to save data. For example, we can use the 7th bit to determine the sign of numbers, 0 for positive and 1 for negative numbers. Now, based on the new standard, negative numbers can be stored as well. As you know, numbers can represent electrical signal values or industrial parameters such as motor speed or water levels. If we need more precision, 2 bytes can be used, which are called a word. Similarly, there are several ways to use 2 bytes to store numbers. For example, the integer format can be used to store a number from -32,768 to +32,767, but the unsigned integer format can only be used to store positive numbers from 0 to +65,535. This table displays some common data types. We will start this course with the Boolean data type, which uses 1 bit. After that, each new data type will be explained during the course. Finally, the third main part of the IEC standard is about programming languages. Each programming language has its own features. This course will be started with the first programming language, the ladder diagram, and then some simple examples of other programming languages will be told. Note that the CFC language is not officially a part of the IEC standard, but is implemented in CODESYS and other PLC development systems. CODESYS is designed based on the IEC standard requirements and can be used to program several PLC brands. The first step is downloading and installing the software. Let's go to the CODESYS website to see how it can be downloaded. At the bottom, click on CODESYS Store. Here you can directly download CODESYS if you are registered and logged in. Otherwise, this window will appear. I created my account already and now I can use that. You can click here to create your account as well. After logging, you can download the version of CODESYS that you need, 32 or 64 bits. If you read and accept the conditions for the download, you can download the setup file. Now I can determine the location on my computer to download the setup file. Note that when the download is finished, you can directly execute the file setup to install CODESYS software. It has a simple standard setup process for Windows. Now let me cancel it because I have already downloaded and also installed it. So let me run it. Let's create a new project. As you see, here are two folders, projects and libraries. Libraries are set of functions, function blocks, software, and so on that can be imported into other libraries or projects. Libraries cannot be directly downloaded on a PLC. Now let's select the projects folder. It includes some projects that can be downloaded on a PLC. As you can see, there are different choices. An empty project, an HMI project that would contain one HMI device, and then the standard project that includes one device, one application, and empty implementation to write or PLC program. The fourth choice is a standard project with some specific libraries. For now, let's start CODESYS with the standard project. At the bottom, I can change the project name and also determine a location on my computer to store the new project. Now, CODESYS asks us two things. What device we are using for this project and what our preferred language is to write the PLC program. Because we are going to use the simulation mode for CODESYS, the device doesn't really matter to us. So based on your system, select one of these two standard devices, CODESYS Control Win version 3 32-bit or 64-bit. Just for you to know, these are meant for systems that use Microsoft Windows operating system. RTE stands for Real-Time Environment, which is a CODESYS extension for Windows. These can be used for applications that need a hard real-time constraint. And finally, these four items are used when some motion controls or motion simulations within CODESYS are needed. For now, let me continue with this one, CODESYS Control Win version 3 64-bit. As you can see, here are 5 languages. Let me select the ladder logic diagram. Finally, by clicking on OK, CODESYS creates a new project. On the left side, there is a hierarchy that helps us to manage the project. It holds everything we need for the project. For example, by double-clicking on the selected device on the CODESYS control Win version 3.64, CODESYS opens the Device tab. Here we can change some settings related to the device, such as its communication settings, get backup and restore information, change some PLC settings, or to determine access rights and symbols that can be used by other PLCs. Now let's double-click on the library management. Here we can see installed libraries. For example, the standard library includes common functions and function blocks such as timers and counters. Therefore, we can use them to write our PLC program. Now let me double-click on PLC PRG. It's the main program unit. As you see, it includes two parts. First, let's define three variables whose data type is Boolean. Note that the selected visibility for these variables is var, so they can be used only inside the current program unit. Now let's write a simple program in ladder diagram language. First, I insert a normally opened contact and then connect it to the first variable A. Now I use a simple coil to store the state of A on the third variable C. This program works like this circuit. To test the program first, we should click on this icon to prepare the program code for our PLC. Because I am not using the real PLC, I need to enable the simulation mode. Now let's click on this icon to log into the simulation mode. Let's close these two tabs related to my device properties and library management and then click on the Start icon. Now I can test my program. This column displays the current state of my variables and the next one displays my preferred values. Let me click here to determine my desired values for the first variable. To perform the desired values, I should press Ctrl plus F7 keys on the keyboard. Based on my program code, the state of the third variable C has changed. Also, I can click on the A contact to select a state for that and then press Ctrl plus F7 keys. Naturally, if I change the state of the second variable B, it does not have any effect on my program performance because I have not used this variable in my program. Alright, the simple program has been tested by CODESYS. Now, the basic Boolean operators will be explained and also used to create basic logics, including AND, OR, and XOR. Then, a simple program will be written and tested by CODESYS software. The ladder programming language is inspired by ladder industrial circuits, and as you saw, the performance of this program is the same as this simple electrical circuit. Similarly, the performance of this ladder program, which includes a negated contact, is equal to the electrical circuit, which uses a normally closed push button. Note that, like industrial circuits, the left line can be considered as the power line in the ladder programming, which helps us to understand the ladder program logic, which is virtual, because there isn't any real power line inside the program code. A simple and a very common program with these contacts and a coil can be this one. Its equivalent circuit is used frequently to turn on three-phase motors or other devices. Nowadays, electrical signals from all push buttons, switches, and sensors are collected by PLCs. Then, based on the program logic, PLCs control their outputs. PLC outputs can be used to turn on small devices directly or high consumption electrical equipments such as three-phase motors by using relays. The most significant advantage of using PLCs is that their program logic can be changed easily without any changes in their electrical circuits. For example, I can change this program easily. I can use the A and B contacts in this form to turn on the output C. This program is known as the AND logic because the output turns on if and only if both contacts A and B are activated. At the bottom, its equivalent circuit is being tested. Note that the program code and the electrical circuit are similar together. Another common logic is the OR one, where if each input is activated, the output turns on. Compared to the previous slide, the PLC program can be changed easily without any change in my PLC wiring, but the electrical circuit wiring has been changed, and also a normally closed push button has been replaced by a normally open one. Let's see another logic performance, XOR. Now the output turns on if only one input is activated. At the bottom, its equivalent electrical circuit is tested. If I change the state of each input, the output state is changed as well. Another important advantage of using PLCs is that they support a variety of instructions. For example, in addition to simple coil, set and reset coils can be used to turn on and off an output. The set coil is only used to set the state of the specified output to 1 or true, for example, to turn on the C output, and the reset coil is only used to reset a specified address to 0. Note that PLCs do update all outputs at the end of each program execution. So if both instructions are activated for the same output, the left program turns off the output and the right one makes the PLC turn the output on. In the next videos, I will explain other instructions such as timers and counters. Now let's run CODESYS to write and test some simple programs. Let's start the programming steps. First, let me define 3 Boolean variables. Now let's use ladder elements to write this simple program. These three icons can be used to add a parallel contact to the program. I need to use this one. Let's use the defined variables. Another advantage of using PLCs is that we can use them to control two or more systems independently. Let me add another network with this icon. I am going to write this program, which is known as the XOR logic. In addition to the above icons, the right list can be used to insert ladder programming elements. For the second program, let's use these new variables. Note that this window appears to define the features of the new variable. As an example, I can determine its visibility or scope, and after the name, specify its type. For now, I need a local variable whose data type is Boolean. The next field can be used to determine the programming organization unit where I must define the new variable. For now, it has only one option. The next part can be used to select an initial value for the new variable. A Boolean data type accepts only two states, true or false. Let's set it to a 0 or false and then click on OK. I will explain other fields later during the other projects. The new variable is defined here. Similarly, let's define two other variables and complete the second program. For this variable, let's select the true mode and its initial state. Now, let's enable the simulation mode and then compile and download the program. Okay, notice that the state of all variables is false except this one, which I selected the true mode as its initial state. So, based on the second program, the variable CC should be on. Let's start the simulator to check out the result. Okay, let's test the program inside the second network, which is known as XOR logic. Note that if I change the state of any contact, the state of the output CC switches between false and true. Remember, to perform any change in any variable's state, press Ctrl plus F7 keys on the keyboard. Similarly, let me test the first program. I can use these two contacts to turn on or off the output coil. Try to write, test and analyze these two simple programs and also others that I explained earlier. Alright, let me exit from the simulation mode. Now we are going to link CODESYS to factory I/O using the KepServerEX software to simulate and control a simple industrial process. You can download the demo version of these two software easily and use them during this course. Well, let's have a short review of the necessary steps to make the connection. Remember, I wrote this simple program. The next step is configuring symbols inside the CODESYS to share with other devices or applications. After that, CODESYS control Win is used to create a virtual PLC. Then KepServerEX software is used to create an OPC server. Note that we need to define some variables in KepServerEX which is linked to my program variables. On the other side, factory I/O can be linked to the OPC server. As consequence, my program can control the equipment inside the factory I/O. Alright, let's start with this program. As the first step, I need to determine which variables can be shared with other devices. So let me right-click on Application and select the Symbol Configuration item. Now I must execute the build command to select variables. Inside the Symbol Configuration tab, I can determine which variables can be shared with other devices such as an OPC server. Here are my variables. Let's select all of them. Again, let me use the build icon and then close the Symbol Configuration tab. The next step is to run my device. It's CODESYS Control Win version 3, 64-bit. So let me find it on my computer and run it. Okay, maybe this error appears for you as well. Also, if I open the code meter, which has been installed by CODESYS, I do not find any license. To solve these problems, you may need to disable your antivirus, but I didn't need it. Then let's find multikey.sys located on this path. Note that I cannot delete this file, so let me rename it. I need to restart my computer. But before restarting, let me save my CODESYS project. Alright, after restarting, I have opened my CODESYS project. Again, let's run my device, CODESYS Control WinV3 64-bit. As you see, at this time, it's working correctly. Also, if I open CodeMeter, I see these two licenses. Otherwise, you will need to use the File menu to import them manually, which are located here. Well, I have run the CODESYS Control Win V3 64-bit as my virtual PLC. Inside CODESYS, let me double-click on the device item. After that, inside the communication setting, let me execute the scan network command. After scanning, select the found device and click on OK. For the first time, CODESYS asks you to determine a name and password for the device. Don't forget the entered name and the password. You will need them later. Note that CODESYS is linked to the virtual PLC successfully. You can go to the users and groups, scan devices, and then change your password. Let's skip this step. Now, let me download the program and configure all the settings into my virtual PLC. Alright, the next step is connecting the created virtual PLC to an OPC server that can be created by KepServerEX software. Now let me create a channel inside the KepServerEX. In this window, select the CODESYS option, but don't change the other settings. Now I want to link the virtual PLC to the created channel. So I can click here or here to add my virtual PLC. Now I need to change the type of the communication to CODESYS v3 Ethernet. After that, let's use default settings for the next parameters, except the address type. Here I select the second option for that. Now the logical address field must be filled. I can find my virtual PLC or device address here. The default port number is detected automatically. Finally, I need to enter my device name and password. Naturally, here you must write your device name and password. Alright, the necessary settings for making a connection between the virtual PLC and an OPC server is explained. The next step is to define some tags that can identify the selected symbols within the PLC program. Remember, I have selected all these variables inside the symbol configuration window. Now I need to define some tags that can identify these variables. Select the added device and then click here to add new tags. Now inside the name field, I write the new tag name. For example, related to the first variable A, I write this tag FIOA. After that, inside the address field, I must write the address of my first variable A. Pay attention to the arrows to know what is the address of the first variable. Now let's determine the variable type. The data type of the A variable is Boolean. Similarly, I need to define 5 more tags related to these variables. Let's use copy and paste technique to define them. Alright, I have created this channel with one device and these tags. Now let's enable my OPC server and check the connection state between the created tags and my program variables. Alright, inside the OPC Quick Client window, let's select my created channel and device. Here are my defined tags, and as you can see, their connection quality is good. Now let's check the created connection between the OPC server and my program. The connection between the CODESYS and OPC server is created successfully. The next step is designing an industrial process inside the factory I/O software and linking it to my PLC program via the OPC server. Its trial version supports all features for 30 days. Now let's design a simple system. To change the equipment height, press V key on the keyboard. The belt conveyor has a motor that I want to control it with these two push buttons. The green one will be used to turn it on and the yellow one will be used to stop it. Now I am defining suitable names for the two inserted push buttons. Remember, this is my PLC program. I will connect the belt conveyor and the two push buttons to these variables. Now let me use two selectors and connect them to these two variables of my PLC program. Finally, let me add a warning light. I connect it to the last variable of my PLC program. Okay, I have designed my system. Now I am going to connect the inserted equipments to my PLC program variables via the created OPC server by KepServerEX. Therefore, let's select the drivers item of the file menu. Then I select the OPC client data access as the factory I/O driver. Now let's click on the configuration option. Let's select the created OPC by KepServerEX. Now let's click on the browse items to find available tags inside the created OPC server. As you see, here are a lot of tags except my tags. I can increase this number to find more tags, but let me use a better way to find the tags. Remember, I started my tags with these three letters, FIO, so I can use these three letters to filter the result. Notice that the factory I/O found my variables, which were defined by KepServer software. Remember, they are connected to the variables which were used inside my PLC program. Now I can connect the equipment inside factory I/O to these tags, which are linked to my PLC program via the OPC server. Alright, all connection settings have been done. Now let's test them. Before that, let me sort my windows to have a better view of the PLC program, OPC server and factory I/O. Now let's test the second part of the PLC program. Based on the XOR logic, when I change the state of any selector, the state of the warning light is changed as well. Alright, the simple program with the Boolean operator has been tested with factory I/O. Thanks so much for watching this video. I see you in the next one.